افتح كوق الإيرث وسوي الزوم على أكبر برية بأمريكا، ألاسكا. من فوق شكلها رهيب، كأنها موجودة هنا من زمان وبتظل للأبد. بس قرب أكثر وشوف ضفاف نهر يوكون. شايف هالبيوت اللي شكلها قريبة بزيادة من الجرف. ألاسكا قاعدة تذوب، وما أقصد الثلج اللي فوقها، أقصد الأرض نفسها. خلونا نأخذ جولة في الغابة. أشجار التنوب هذه ما هي واقفة سيدة. عشين كذا السكان المحليين يسمونها الأشجار السكران، كأنها خلل بمحرك الجرافيكس، لكنها علامة تنبيه. الأشجار هذه تطيح لأن التربة الصقيعية صارت كأنها شرطة. ب85% من ألاسكا الأرض متماسكة بالجليد. كنا نحسبها صخر صلب، وجاء الاحتباس الحراري. الولاية تسخن أسرع بمرتين ل3 من باقي أمريكا. أحسب إنها مو مشكلتنا. أخبار سيئة. حسب توقعات المناخ وبيانات تقرير القطب الشمالي منه، الوضع بيصير حرج بحلول 2050. نتكلم عن 40% من الأرض الصلبة في هالمناطق بتتحول لطين غير مستقر خلال 30 سنة. لما يذوب الجليد اللي تحت الأرض، هيكل الأرض ينهار، وهذا كأنه درس جيولوجي في الواقع. قرب أكثر على قرية نيوتوك. هذا مجتمع أنسح حرفيا من الخريطة. الأرض اللي تحت بيوتهم قاعدة تتحول لطين وتنجرف للنهر. لازم نسمي سكان نيوتوك أول لاجئي مناخ في أمريكا. أخيل إنك تنجبر تلم كل شيء، حتى بيوت كاملة، وتنقل 9 أميال عشين تلاقي الصخور الصلبة، وهم الوحيدين. فيه أكثر من 30 قرية في ألاسكا تواجه نفس المصير بالضبط. وش اللي مخبى تحت الأرض اللي تذوب؟ نباتات، حيوانات، وكربون قديم. الحين الميكروبات تصحى وتأكل المواد العضوية، وتطلق كميات ميثان تخلي كوكبنا أخني. وكل ما زادت الحرارة زاد ذوبان الأرض. المرة الجاية لما تشوف خريطة أمريكا، لا تطالع بس سواحل فلوريدا أو كاليفورنيا. ناظر شمال، لأن أكبر ولاية بأمريكا مو بس تتقلص، هي تذوب.
7,500 years ago, the Pacific floor collapsed. Massive landslides buried the seabed in seconds. Fast forward to today, robot subs have examined the place. Scans have revealed proof of at least 10 distinct cyclical megaquakes. Now, researchers warn, the plates are still locked and building pressure, even today. If they start moving, that could trigger new red alert earthquakes and send disastrous tsunamis toward the coast. Let's look at the map. The fault here is like a giant zipper. It's over 600 miles, stretching from northern California to Canada. It's called the Cascadia Subduction Zone, and it's a part of the Ring of Fire. You know, the famous giant horseshoe around the Pacific that can serve as your where-to-go reminder if you're into volcanic and earthquake tourism. One of Cascadia's biggest events happened around the year 1700. There are no local written records of it, but there is a story. A well-known indigenous legend tells of an epic battle between a thunderbird and a whale. In the story, the thunderbird's wing beats make the ground shake. The whale's thrashing sends seawater flooding inland. The thunderbird wins by finally grabbing the whale and slamming it back down, shaking the land itself. Many researchers believe that this legend originated from the real earthquake of 1700. But we don't just have cool myths to give us the full picture. In the early 1700s, samurai officials recorded waves flooding villages and rice fields. But nobody felt the earthquake that must come first. That's why they nicknamed this event the Orphan Tsunami. But it did have a parent, and it took scientists 300 years to finally connect it back to Cascadia. To see Cascadia's past, researchers sent robot subs to scan the bottom in crazy detail. They expected to see a simple crack, but what they found looked more like giant underwater steps. Some of those steps are about 33 feet tall, like a 3-story building. That only happens when a big piece of the seafloor snaps off, breaks loose, and slides all at once, not slowly. When that happens, it kicks up a mud avalanche. Picture a jar of dirt and water. Shake it hard, and a fresh layer settles at the bottom. Each layer is basically a timestamp from a huge quake. When scientists counted and dated them, they found 10 separate megaquakes that hit one after the other over thousands of years. That means that Cascadia doesn't let pressure out little by little. It stays stuck for a long time, then suddenly breaks out violently. That pattern is why the Cascadia subduction zone is considered one of the scariest fault systems in North America today. So what's actually happening down there? The plates aren't sliding smoothly, they're stuck. And while they're stuck, the coastline is getting quietly bent out of shape like a ruler you're flexing in your hands. It doesn't look dramatic day to day, but it's been loading up for centuries. When that tension finally snaps, the coast will instantly drop. Geologists call this co-seismic subsidence. We're talking about the ground plunging 6 to 8 feet vertically in a matter of minutes. Imagine standing on a beach. The shaking stops, and you realize the ocean is rushing in. Not just because of a wave, but because the land you're standing on has physically sunk below sea level. That one move is enough to shove the seafloor out of position and force the ocean above it to react. Cascadia can produce a magnitude 9.0. That's top tier, categorized as the most destructive natural event that can happen. It can shake the ground for minutes, pushing and pulling everything back and forth until buildings and bridges start falling down. A 9.0 class quake also means the seafloor is vibrating and shifting, lifting in some spots, dropping in others, all in one sudden motion. A tsunami starts when the seafloor moves and pushes a huge amount of water out of the way. If the bottom suddenly lifts or drops, the water above it gets displaced instantly. That water has to go somewhere, so it races outward in every direction. Out in deep water, that wave is rarely tall. It spreads out across a long distance, so it can pass under ships without anyone noticing. The danger is speed. In the open ocean, tsunamis can travel around 500 to 600 miles per hour. That's like traveling from New York to Detroit in 60 minutes. Eventually, the ocean starts to pile up, getting taller by the second. Near shore, it can stack up to tens of feet, and in extreme cases, it can run up to 100 feet on land. It swallows the coast, then drags everything back to sea with a violent tug before the next hit arrives. But that's not all. When the fault snaps, it often triggers massive underwater landslides. When a huge chunk of seafloor collapses, it can shove water locally, like dropping a boulder into a tub. In the Cascadia subduction zone, you aren't just dealing with the earthquake's kick. You're getting a 1-2 punch from the shifting crust and the crumbling slopes combined. On parts of the Oregon coast, emergency experts say the shaking could last 5 to 7 minutes, long enough to realize what's happening and still won't be over. Then comes the scariest part. In some places, a tsunami can hit in 15 to 30 minutes. Remember, the earthquake is a warning. If you're on the coast and you feel strong, long shaking, you do not need to wait for a text alert or a siren, or someone on the news to yell tsunami. During the tremors, the basic recommendation is to literally drop to the ground, cover, and hold on, staying away from windows and chandeliers that can fall on you. As tempting as it is, we shouldn't stop to make a reel out of the situation. Before anything happens, make one decision while your brain is calm. Pick the closest high ground and go for it. Not somewhere uphill, an actual spot. If you ever needed a reason to learn your neighborhood, this is it. Your instinct might say, get into the car and drive. But don't. Roads are probably jammed and bridges could be damaged. People who live on the coast already know to keep it practical, with shoes on the bed and a go bag prepared just in case. The danger doesn't end with the first impact because the tsunami waves, well, they come in waves. The initial hit is rarely the largest, and the ocean can continue to pulse in and out for hours. This creates a violent tug-of-war. the receding water acts like a massive vacuum, dragging anything caught in the backwash out to sea. Japan's 2011 disaster is the most recent vivid example of what a magnitude 9.1 can do. The seafloor shifted in a single massive heave, and minutes later, the ocean literally rearranged the coast. A huge wall of water crashed inland, reaching over 100 feet high in some spots, and turning the coastline into a conveyor belt of debris. It was like water turned cars into giant bowling balls and shipping containers into massive metal bricks, smashing ports and drowning low-lying airports and electrical substations. Finally, what do officials say about the timeline for the possible next disaster hitting Cascadia? Well, they can't give us precise dates, but they did announce some odds. For the biggest, scariest earthquake possible, the United States Geological Survey says there is about a 10% to 15% chance it'll happen in the next 50 years. Chances for a quake that isn't the mega version are 1 in 3 in the next 5 decades. Those odds are actually pretty high. But here is why it isn't all that grim. Scientists know this isn't random. Cascadia has a pattern, and patterns are what preparation runs on. We already know how to build for big shaking, and we're getting better at spotting where stress is building. It doesn't mean we can stop the earthquake, but it means we're getting way better at knowing what to expect. In the meantime, just keep a go bag by the door and maybe take a walk around your neighborhood every once in a while. It's one of America's strangest contradictions. The Northeast, the cradle of cities, commerce, and crowds, hides a vast, empty wilderness at its northern edge. Millions live packed together to the south, yet up here, there's space for everyone, and almost no one takes it. How did this happen? How did the heart of America's most crowded region end up with one of its loneliest frontiers? The northeastern United States is home to more than 50 million people. It's one of the busiest and most densely packed regions in all of America. But almost 90% of those people live in the southern half of it. If you go north, past big cities and highways, everything will change. The noise will fade and the lights will thin out. You'll find yourself in a different world. A quiet land of forests, lakes, and mountains, stretching across northern New York, Vermont, New Hampshire, and Maine. This is America's empty Northeast. And the mystery is simple. Why is this part of one of the most crowded regions in the country so empty? First of all, let's take a look at New England itself. Massachusetts and Rhode Island are bursting at the seams, while Maine, Vermont, and New Hampshire feel wide open. Connecticut sits in the middle, literally and figuratively. Massachusetts is basically the crowd magnet. Most people live around Boston and the cities nearby, Cambridge, Worcester, Springfield, where everything's close, busy, and built up. Rhode Island may be tiny, but it's got a big city density. Connecticut sits right between Boston and New York, and it shows. It has a busy coastline and quieter inland towns. It's not too crowded and not too empty. The middle ground. Once you cross into New Hampshire, things slow down. There's Manchester and Nashua, but most of the state is forests, lakes, and open land. Then there's Vermont, easily the least crowded region of the bunch. The Green Mountains slice through the middle, and most people live in small towns or villages. And Maine is huge and mostly empty. Most people stick to the southern coast. If you head north, you'll hit endless forests, lakes, and long, quiet roads. It's beautiful, but it feels like the edge of the map. Today, the northern half of the Northeast, northern New York, Vermont, New Hampshire, and Maine, holds only about 4.9 million people. That's roughly the same as the population of the Boston metro area alone. To put that in perspective, if you take southern New York and southern New England, about the same land area, you get 10 times as many people living there. So, why the gap? It all comes back to geography, history, and economics, and how they've always worked together to keep the North empty. Let's start with the land itself. The thing is, the farther north you go, the rougher the land gets. Southern New England and downstate New York are full of rolling hills, wide valleys, and coastal plains. But then come the mountains. They're old, crumbling, and wild. In northern New York, you'll see the Adirondacks. To their east, the Green Mountains run up the middle of Vermont, stretching into Quebec. Keep going and you hit the White Mountains of New Hampshire. They're home to Mount Washington, famous for some of the most severe weather on Earth. And beyond that, the western Maine Mountains roll on toward Canada. Those aren't gentle hills, they're real barriers, and they owe their shape to one of the most powerful forces in Earth's history: ice. During the last ice age, huge glaciers covered this land. When they finally retreated, they carved out deep valleys and left behind thin, rocky soil. Later, the basins filled with water, creating thousands of lakes and ponds. It's a beautiful but difficult land to live on. Farming never stood a chance here the way it did farther south, where the soil is way richer. So the mountains stayed wild, covered in dense forests that even today stretch for miles. Northern Maine and the Adirondacks together make up one of the largest continuous forests east of the Mississippi. For centuries, people have come here to cut timber, fish, or hunt, but never in great numbers. And then there's the weather. Up here, winters are long, dark, and cold. Snow piles up early and doesn't leave easily. Summers are short, and the growing season is barely long enough to farm. It's not exactly a place that says, "Come start a new life." But of course, some people did. And here's where history comes into play. Long before Europeans arrived, this land was home to indigenous nations. The Abenaki, living across Vermont, New Hampshire, and Maine, had complex trade routes, connecting their communities all the way from modern Quebec to Massachusetts. Farther west, the powerful Iroquois Confederacy extended its influence toward the Adirondacks, controlling vast hunting grounds and trade routes. Then came the Europeans. In the 1600s, French explorers and fur traders pushed south from Quebec. They set up outposts along rivers and lakes that linked the region to Canada. They saw opportunity: furs, fish, timber, but not farmland. The dense forests and harsh winters kept settlements small and scattered. The English, expanding north from the Massachusetts Bay Colony, took to the coast. They settled in southern Maine and New Hampshire, but going inland was another story. Between the cold, the forests, and the resistance from native nations, their progress was slow and dangerous. For more than a century, the interior of the northern Northeast stayed wild. Later, around the 1760s, the British took control of the region. Land speculators moved in, especially in Vermont, which both New York and New Hampshire claimed as their own. The overlapping claims led to chaos, and eventually, Vermont declared itself an independent republic in 1777. For 14 years, it existed on its own until it joined the United States in 1791 as the 14th state. New Hampshire pushed inland from the coast, building towns in the valleys between its granite mountains. Maine, meanwhile, spent centuries as parts of Massachusetts. Its economy ran on timber and shipbuilding. Trees turned into masts and planks for the growing British and later American navies. And in northern New York, the Adirondacks remained a wild frontier long after the rest of the state filled up. The land was too rugged and the winters too fierce. Logging, mining, and later tourism would bring people north, but never in huge numbers. By the mid-1800s, the southern parts of New England were booming. Cities were growing, factories were humming, and immigrants were arriving in large numbers. But the northern regions stayed quiet. So as we now know, the mountains are the first big barrier. They make everything harder: travel, building, farming, and surviving winter. The soil is thin, rocky, and poor. And what's underneath isn't much better. The region doesn't have rich mineral deposits or coal seams like the Appalachians farther south. Without valuable resources to mine or easy land to farm, there wasn't much reason for settlers to stay. That was one of the reasons why the economy never took off. The empty Northeast never became a center of industry. Southern New England had rivers that powered early factories, ports connected it to global trade, and the cities attracted millions of immigrants. Northern New England and Northern New York had none of that. They had lumber, granite, and paper mills, all useful, but those industries didn't create huge cities. Even today, the economy up there relies on the same resources, along with tourism. People come to hike, ski, fish, and escape city life, but most don't stay year-round. Towns fill up in summer and fall, then empty out when the snow starts falling. A few small cities, Portland, Burlington, Manchester, thrive, but there's no Boston or New York up here. You won't find massive universities, corporate headquarters, or international airports to pull in young people and families. In fact, some states have gone so far as to pay people to move there. Maine and Vermont have both launched programs offering money to remote workers who relocate. That's a pretty desperate attempt to reverse decades of population decline. Today, this empty Northeast holds just about 1% of America's population. It's a land of deep woods, icy lakes, and quiet towns. The wilderness never really left this region. But that stillness is also what makes this place so special. The rest of the Northeast is filled with constant noise and motion. Meanwhile, the North is a reminder of what the region once was: wild, cold, and untamed. That's how the heart of America's most crowded region remains one of its last true frontiers.